Hello everyone. So this is a continuation of design pattern. Behavioral design pattern. We are discussing state design pattern. Now I will talk about the next topic, that is chain of responsibility design pattern, a behavioral design pattern. I'll show you how what actually it is, how it can be implemented. Right. Let me share my screen. Yeah, my screen is visible to you all. So here we go and start the chain of responsibility design pattern, right? Yeah, I'll just give a problem statement first, and then I will explain what it is exactly, the design pattern, right? Uh, the code design pattern. Before going to problem statement and code design pattern, I will let you know what is your chain of responsibility design pattern, right? Chain of responsibility design pattern. So see, this medium, whatever this has done, the same kind, similar example I'm explaining. I'm done the coding of similar example and I'm explaining the similar example there. The same implementation, I think so. Yeah, the same implementation, similar kind of implementation, exactly similar kind of implementation. The same, yeah, I can say 100% same, right? The 100% same implementation I have done in my Eclipse. I'll explain that. See what exactly chain of responsibility design pattern. The chain of responsibility design pattern, what actually it says, what actually it says, right? See, the chain of responsibility design pattern is a behavioral pattern that allows an object to pass a request along a chain of potential handlers until it is handled by an appropriate object. See what happens now. I will what it exactly trying to tell you. If you are a if you are an engineering student or a college student, you have to take a approval from your sir, right, or from your class teacher or from your professor for a leave. If you are taking a one-day leave approval, you can directly done by your professor or your class teacher or maybe at that level it can be done. Let's say you want to take a leave of 2 months. Now who will be able to approve it? First, your class teacher will take. She will. A class teacher will see. Okay, this is for 2 months or 1 month approval, leave approval. I can't give. He will pass it to your his senior authority, maybe vice principal of the college. Then vice principal will say, I have the capacity to pass 1 month. I cannot pass or I cannot approve 2 month leave to a student. So what he will do? He will pass it to the principal. Now principal will consider your application and then he will, based on some condition and criteria, then he will either he will approve or he will reject it. Right. So here, if you see, it's a chain of responsibilities. Right. The first is your class teacher, then vice principal, then principal. It goes to you submit your application to your principal, from it goes to the vice from your sorry, you submit your application to your class teacher, from your class teacher it goes to the vice principal, and from vice principal it goes to the principal, right? So this is the approach which you take, right? Similarly, there will be different situation and scenario where this kind of problem will come, where one has to approve based on certain criteria, and if that criteria is not matching, he will not approve. He will send it to senior, and if senior not approving, if his senior is not able to approve it because of some criteria conditions, it will go to his senior. Like so, that's how in corporate world or in maybe in government offices or maybe in any department, they work in that particular structure. So if you want to implement that particular chain of responsibility or that behavioral changes in your Java code, how you can do it? How you can do it, right? How you will be able to do it? Here, I have taken, that for this example, I have taken from the Medium website rather creating a one because, writing my own might take some time. I have taken this example from the Medium. You can go and read in the Medium the theory and the program also you can look into it. See, here, first you need to have a request handler, which is really going to help you or handle your request. In this kind of situation, you always need to have a request handler that will help you, that will help you to proceed, that will help you to take care of your, that will help you to take care of your situations, right? So first you need to have a request handler. What is the purpose of request handler? Request handler is kind of a, it's basically uh, a class which is going to take care of your request. If I talk about the approval request, it is going to take care of your approval request. It is going to take care of your approval request. And now, what will be the approval request? How we are going to define based on what criteria it is going to approve that application. Here, in this case, the example is manager, senior manager, and director. Manager has certain level of authority. Based on that, he can approve. And if it needs above that, manager will go to senior manager, and then senior manager will go to director. In one of my company, I had to, I had to give some kind of rewards to my team members. We have monthly rewards and quarterly rewards. So for these rewards, I need to get approval from the director for the resources whom I am referring. Right? So if my director approves, then my resource will get the rewards for that particular month or for particular quarter or half yearly or yearly, right? That's how it is. So what happens? I have to to approach my director. I can approach my director directly, or I can go through the sequence or through the steps. I have to go to my manager, my manager, that is senior engineering manager or senior manager, or to his senior manager, then to his senior manager, based on your hierarchy, organizational hierarchy, what kind of hierarchy you have, right? So I was the manager, so I went to my director and get it approval done. If my resources are asking for leave, that leave approval is up to me. I can give, and I don't need any approval from my director. If my resource is saying I will work from home, that is up to me. I don't need my director approval. If one of the resources is asking, I want 6 month work from home or 1 year work from home, I will not come to office because of some reason, blah blah reason. Then I don't have that approval. As a manager, I will go to my director. If my director is not having that approval, then he will go to his senior, right? So based on the condition and criteria with certain authority, every individual has his certain authority and some restrictions. That authority will help us to deliver our responsibility, and the restriction which I have or the manager is having, that restriction he will not be able to deliver. He has to go to his senior. And if his senior is also having the restriction, then he also has to go to his senior, right? So basically, who will handle this particular state, right? Particular responsibility, kind of responsibility, right? So that's how it is. So here, see, this equational class is going to handle the approval. Right? This is a simple class which is going to handle the approval, right? So if you see this particular class, string, name, request handler, private request handler, this particular uh, class is an abstract class, and the constructor is private request handler, the default constructor. And default constructor, even if you don't write also, that is fine. The next constructor, public request handler, string name, this dot name equal to name. Whatever the request handler is coming, that name is there, right? And it has a method public abstract void nest set nest. Abstract this has an abstract method set nest, and it has a method public void approve int id, and that method is implemented. What approve method is doing, if this dot next handler is not equal to null, this dot next handler approve id. That id is passing to approve, right? Else system dot out dot println request cannot be approved, right? So basically, what it is trying to tell, if it is not approved and if it is calling the next handler, then next handler should call the approve, right? So the thing here, if you watch the class how they are implemented, you will understand. See, senior engineering manager, first we go to manager, the lower level manager, right? Manager extend request handler. Here it is public manager, super manager. It is calling the request handler class method and passing that this is the manager who is calling you. That is manager is calling the request handler, right? Then public void set nest request handler nest handler this dot nest handler. This is a method which we are implementing. But basically we're trying to tell, in case of manager, if manager is not able to approve it, set it the nest handler, right? Set the nest handler. If manager is not approve it, set the nest handler, that is senior manager, and then the same approve method. And here the restriction is manager can only approve ID 1 to greater than or equal to 1 and less than or equal to 2. Manager can approve. Right. This is one of the criteria, condition criteria. Now going to senior manager. Senior manager, here also same thing, it is setting, if this is not able to approve, it will go to the next handler. Here what is saying, approve ID is greater than or equal to 21, ID is less than or equal to 40. Senior manager will be able to approve if ID is greater than or equal to 21 and less than 40. Then director. It is also same implementation, only the change in the restriction. Here you see, either it override public void set next request handler, this dot next handler equal to next handler, right? And public void approve is same. Only the difference is public ID greater than or equal to 40 and less than or equal to 80. Director will be able to approve it, right? So if it is that, send request approved, else call super dot approve. What is super dot approve? Super dot approve is request handler. It will go to request handler. It will call this dot next handler is not equal to null. Yes, it's not equal to null. This dot next handler is approve ID. Yes. So it will call to the next handler, right? If it is not able to approve, it will call the next handler. And if it is, it will go like that. At the director, what is happening in director super dot approve, here there is next handler is what, if you have senior director, your next handler will be senior director. If you don't have senior director, then this will be null. So let's go to the main program. Keep on, keep on is always the nice statement. Keep on, right? If you are learning, keep on learning. If you are growing, keep on growing. That's how it should be, right? See, I will tell you how it is happened. How it is happening. See, all of them are created using request handler. All the instance variable is request handler, and the objects are manager, new manager, senior manager, and director. This is how it is. Right? I will show you here by adding one more senior director. Just see how it is working, right? See here what we're doing, manager dot set next. In manager dot set next we have set senior manager. Senior manager dot set next we have set director. And director dot set next is nothing there. That means it will be by default null, right? Manager dot approve is your, I'm giving 81. That means who will approve it? Let's go to first manager. Request approved by manager. That will make clear, right? Let's go to senior manager. Request approved by director, right? I liked this example. That's why I've taken it from the medium. It's a very good example. Everyone can understand easily. See now what happens when I run it. You will see what it is exactly saying when 81 I have given. That means it is beyond 80. So director cannot approve it. Who has to approve? Senior director. See, request cannot be approved. Now if I give, let's say 19, so who will approve it? Manager, right? Request approved by manager. So it is not required to go to the next state. See, here the criteria for request is approved by manager and the program will end here. Otherwise, if it is not approved by manager, it will go to the else part and then it will go to the super approved ID. See, the other way, if you are not able to understand, even if after explaining it, you can always download this program from GitHub and then put debug, put a debug point in your main method and then step into step over, debug line by line. Run the application, run as debug, run as debug. I will show you that also for your, see, you can always put a debug point here in line number 42 and then right click, run as or debug as Java application. And then you will get from where this program is going. See, it will open a debug mode and it will show where the program is going. Manager.set next, right? It is in this. Here, if you see my mouse pointer, there is something called step over, means it will not go inside the next method. It is step into. So click on step into. It will go, you will see it is going to the manager and setting the handler. And then step over. It will come outside. Then again step into. See, it is going to senior manager setting the handler, that is director. Then step over, come out. Then go to approve. Next. See, it came to the ID is greater than equal to and ID less than 20. Next step in. You can do always step over after getting into that if you don't want to get into inside. Now, if I do step into it will take me into the system.out.println method. So here I need to do step over, step over. Program got over, it came to the end curly braces, it will come out of the program. Right? So if I make it, let's say 39, what will happen? See, just what? If I make it 39, see how it will go. I will just proceed. I will go to the line number 47. Directly step over I will do because you know what will happen in the set nested, step over. Now here I will do step into in line number 47. See, it came to this. If ID greater than equal to and 1 and less than equal to 20, then again step into. It directly went to line number 19 support.approve ID. Then step into where it came to the request handler, right? Approve method. This dot next handler is not equal to null. Then it will go to the approve ID again. Next. Yes, this dot next handler is not null. So it went to this dot next handler dot approve. That is to the senior manager. Right? See, it came to senior manager. Public void approve int ID greater than equal to 21, ID less than equal to 40. It is input in that range. So it will print and it will come out. So this is how you can always run a program to understand how it is working. Approved by senior manager. I will show you one more implementation here. I will add, in this chain of responsibility, I will add something for senior director. One more implementation I will add senior director. Hold on. Here I will write senior director, and then directly here itself you can add a request handler, right? Request handler class is this one, design pattern, and then finish. So this is the method I got, right? I have to override this method. What it is trying to say, add constructor. Yes, that is how. See why it is forcing us to add a public constructor with a parameter. The reason behind that, in the request handler we made this default constructor as a private. That is the reason. Now this director, senior director, manager, they don't have the default handler, a default constructor, because your parent class default constructor is private, so it will not have the default constructor. So you have to definitely have a parameterized constructor. That's how it is. Here we'll pass, but senior director, and here this dot next handler equal to next handler, right? This is what we will add it here, and this will also have a approve method. I will just copy that same approve method, but only condition will be changed. This I will make it greater than 81 and less than equal to 100. This is the only change I will do it here to show you how this can work. I would have done the same thing in case of state pattern also. I would have added one more flow and shown you, but anyway I missed it. Then I realized, okay, in coming session I will add one more, chain of responsibility. I will add one more responsibilities, one more uh, one more chain of responsibilities, and show you all, so that you will understand how actually it works. Let's go to the now main method. That's all we have done here. No more changes, nothing. Here the thing is, here you have to add, you know, director dot set next. What is that? Senior director. Before that, I have to create one more senior director object here. See, I can directly do here also. I can directly write here also. Senior director, right? I can write directly here also. So see, here you can create your own. See, since I just want to explain something about this constructor here. See, in the request handler, is constructor is private, right? This constructor is private. Now what happened in senior director? I am extending request handler, and I want to have my default constructor. I cannot write default constructor like this, empty. If my request handler is public, then I can write that way because it will be visible, as a specifier. Now see, there will be no error in default constructor because I have made this request handler constructor as public. The reason behind that, to senior director or to the director, to manager, to senior manager, the classes which you have here, this the parent class constructor will not be visible. That is the reason it will not be correct. But what you can do if your parent class, if your parent class constructor is private, right? If your parent class constructor is private, always what you can do, you can do public, like this, senior director, then super. And in super, what I'm doing, I'm calling the parameterized constructor, which I already created in request handler. In request handler, you see there is one more parameterized constructor, right? Where it is taking request handler, then name. Who is that particular person is invoking this request handler, right? So in that way, we're able to do. We're calling the parameterized constructor in our default constructor. So that is how we can have a default constructor in senior director or manager or senior manager, right? This is how. So this is the state I added. Now let me go and show you the example. Here, it is not required anything here, right? Yes. So directly I added in line number 45, you see director dot set next new senior director. That way also you can add, no issue. Now by adding 80, I have shown you request. By adding 81, I have shown you what is said. Request cannot be approved, right? Now if I add here what 81, it will say request approved by, it will say request approved by senior director. Request approved by senior director. So like that, you can always keep on adding, like that you can always keep on adding your chain of responsibilities. And this is how the chain of responsibility design pattern. You want, you can read all these theories, right? The chain of responsibility design pattern is behavioral pattern that allows an object to pass a request along a chain of potential handlers. Here, this manager, senior manager, director, senior director, all these are chain of what? All these are chain of potential handlers. These all are implementing the request handler. That's why they are chain of potential handlers, and you know, and they will be moving from one handler to the other handler until unless one of the handle the request. For the handler who will handle the request from that particular handler, it will come back to us, or to the caller, or to the main method, right? This is our chain of responsibility. So that's how it is. The behavioral pattern is this is how there are so many behavioral pattern. So many behavioral patterns are there. Where is that diagram? Let me go to the diagram. Yes, this is, see, template method, meditator method. Template method, basically kind of a template will be there, and everyone will use that kind of template. So chain observer, strategy, command, state, visitor, iterator, interpreter, momentum, all these are behavioral design pattern. You can go through all them in any of the website, Medium, in the Geeks for Geeks of Geeks, Hacker Rank. So many websites are there. Tutorial Point, Job Point, so many. You Google, you will find so many websites with all this design pattern. Go through it. If you are not able to understand, you can always connect me. Right now, let's go through the structural design pattern. In structural, you see composite, proxy, flyweight, facade, bridge, decorator. All these design patterns, right? So I will explain you what is facade and what is bridge design pattern here by implementing. Others, you can just read and you can be able to know what are the design patterns. Coming to structural design pattern. See, what is the general English meaning of facade? Anyone? This is general English meaning of facade. Hmm. Yeah. So these are the classes. I've opened all the classes. Now I'll explain. Before that, we are talking about facet design pattern. So what is a facet design pattern? Some theory. Okay, let's go to the medium again. Right, I click that. So see, the facet design pattern is a structural pattern that provides a simplified interface to set of interfaces in a subsystem, making it easier to use. It involves creating a unified interface that sits on top of a set of interface, right? To simplify the uses of client. See, this is a little bit complex. I will tell you in another way. If asset design pattern structural design pattern is simplified interface to complex system, making it easier to use. It acts as a gateway, shielding the clients from the intricate details of subsystem internal working. See, basically, facet in general English, what does it mean? In facet in general English, what does it mean? You know, the principal front of building that faces onto a street or open spaces, right? That is your facet in general. There are so many meanings. See, here it is given a deceptive outward appearance. So basically, what happened? Outward appearance, that is outward appearance. Whatever you see from the outside, what is happening behind, it won't show you. What is actually happening behind, you won't come know. It basically what it does, it create an abstract layer. It gives it it is kind of abstraction. Basically, it is kind of hiding. It hide how the things are happening, behind. It will show you in front. It will show you that okay, this class is doing everything, but that class will not be doing everything. Some other class will be doing the actual implementation class will be some other class. You call a class, you feel that this class is doing all the, like here you see banking facet, you see line number 15. I'm creating an object of banking facet, a new banking facet. You see banking facet get account details. So you'll be thinking this banking facet application is calling the get account details, and this class is actually performing the operation and giving me the account details. No, it may not be, right? But it is giving an impression of that banking facet transfer funds, banking facet dot pay bills. It is giving you an impression. It is giving you an impression of that. What banking facet is doing everything. Banking facet is kind of a gateway. It is not doing everything. It is a kind of a gateway. It just call the right or appropriate service to perform that particular operation. It for get account details, it will call the appropriate service of get account detail and will perform the operation. How does it does? How is it happening? How is it implemented? Let's go and see. See here when we're talking about as an architect or as an engineering manager, as a as a part of technology, if you're working, then you will have all these knowledges. If a professional is watching all this, and he has worked in technology, if he's a director or senior director, then he might have implemented all this. For me, I have already implemented all this. But nowadays, we are not implementing. We already have framework. If I start working, use Spring AOP, it will perform or it will create the facet design pattern for us. We need not to go to worry how to implement facet design pattern. Right? So, if you are working as a project manager, purely project manager, then you may not be having this all knowledge. If you are technical manager or engineering manager, you know, tech plus management, then you will have these knowledges. So here, why all this coming into picture? You know, these I'm telling so that the people, those who are watching this video, if you want to grow into a tech managerial stack, tech plus management, then you need to understand this, how it is implemented, where it can be used, and how it is used currently. Are we writing code, or is any framework or any open source framework providing these implementations? If you want to make your career as a tech career, you need to understand this, learn this. You can always comment me, message me, mail me, or go and read it from internet. So many sources are there available on internet. Go and read there. If you have any doubt, you can always mail me, message me, or comment on the video description. So here, banking facade, get account details, transfer funds, pay bills. If you see from from this layer, it will show you as if banking facade is doing everything. But no, let's go to the banking facade. What it is doing? See, banking facade is the gateway. It is the gateway to all other services. That's how the facade design pattern. Facade design pattern will hide the actual implementation layer in the form of a gateway. So your banking facade, right? Banking facade, this dot account service equal to new account service. This is the constructor of the banking facade. This dot account service equal to new account service. This dot transfer service equal to new transfer service. This dot bill payment service equal to new bill payment service. What it is doing inside the constructor, it is creating an object of all other services. So that when you call get account details, it will use that service, that instance of that service or object of that service to call actual get account detail method where the actual operation is performed. It will use the transfer service where actual the fund transfer is done. It will use pay bill, uh, bill payment service where actual bill payment is done. So here I have the same class account service class which is doing actually or which is actually performing the business logic of account details. Here always it is SOP, so don't you know see, this is only to show how the vision pattern is implemented. So don't worry or don't get into the SOPs. Now if you go to transfer service, transfer fund is there. It is implementing how the fund is getting transferred, right? If you go to bill payment service, the same thing, you'll find pay bill. The actual methods are implemented in their own service classes, but it seems to outside world like business facet has implemented all the methods, right? This is how it is. Um, Let me go and run this main method, right? So below that, I have one more design pattern. Right, let me comment it out. That is a bridge design pattern. Let me comment it out. So only I'm going to run this facet design pattern. See, facet design pattern, the SOP. Then saying fetching account details for account ID 1 2 3 4 5 6. Then we're saying transferring 100 from account to account this. Then paying bill this. This is very simple. See, I have explained it. These all design patterns are basic design patterns and it is very simple. You can easily understand it without any headache. Right? Facet is very simple. You can easily understand it. Now here, I'll go and explain you one more design pattern from the structural design pattern. That is your bridge design pattern. You know, what is bridge design pattern? Why we need a bridge design pattern? That all will come into picture now. So let me go to this guy, what we're writing chain of responsibility, right? This is chain of responsibility. Let me close this guy. I was showing you the meaning. Now, why we need fashion design pattern? Any idea where we need, why we need? So see, fashion design pattern is needed in similar kind of situational scenario where you need to have a gateway, and that gateway will connect. That gateway will connect to the other side of the services. Bridge design pattern. Let's go to the same medium website. Yeah. So see, bridge design pattern is also a structural design pattern and a handy tool that helps us keep our code organized and flexible. It's like a bridge that connects different parts of our code, making them work together smoothly. The bridge pattern is used to separate an abstraction from its implementation, allowing both to evolve independently. Right? So what is bridge design pattern basically? The structural pattern which help us keep our code organized and flexible. It breeze that connects different parts of our code, making them work together smoothly. You know, it basically create a breeze or connects different part of our code, making them work together smoothly without any conflict. Right? That's all. So if you see this program, you will be able to understand how it works. So here, if you see, I have one after class SC right? So I said, and initially, if I have a class for after class, I'll make it as SC. And then I have one class called SMS sender. I have one class called simple message. I have one interface called message sender. I have another class called email sender. So what is the actual situation or scenario here? Here the situation is here. I'm going to uh, create a kind of bridge or connectivity between classes where you send one message, you send messages without worrying about different constant or artifact, right? So, for example, your SC message class, this abstract class message class, hold on, okay, that one, man, simple. Yeah. So what happens here? See, there is basically kind of a simple message and there is kind of a email. You send a simple message, you send a email, right? And you can send a SMS. Right? So when you send a SMS and email or simple message, how they work with each other, right? How they work with each other, right? So that is this example is going to show here. See, here I have, here I have one SMS sender. Here I have one simple message. Here I have one simple message. Here I have one abstract class message, right? So when I'm talking about email sender, what it actually does, it inherits the class called I message sender, interface message sender. So what does interface message sender does? Interface message sender has a method called void message. It's an interface, right? This interface defines the operation that need to be implemented by platform specific classes, right? So you want to implement send message, and then coming back to email sender. Email sender is implementing that to send the message, like sending SMS messages, email sender, or sending email, whatever message you want to send, right? Send email messages here. Now, when you're going to SMS sender, this will send SMS. SMS sender again implements iMessages, right? And here it is sending SMS messages, right? Now, if I come to simple message, what does simple message does? It extend SC message. What is SC message? SC message, it defines high-level interface for sending messages. It uses platform-specific sender message to the send message, right? What it does, it is, SC message defines the high-level interface. Kind of a similar to interface. At a high level, it is defining same, it is creating an object of iMessage sender, right? In that abstract class, iMessage sender, sorry, not object, instance variable of iMessage sender, that is message sender, and protected SC message sender is the constructor, right? And then the send method is abstract, right? The send method is your abstract. We have not implemented the send method because it's an abstract class and it's not required to implement. Who will implement this? The implementing class. The implementing class is simple message. What simple message does here? Simple message extends your SC message. This simple message sends the simple message create object using a parameterized your constructor where it passes it in parameter it pass message sender, that is I message sender type, interface type instance variable to the superclass. Now problem in this, it implemented that sending simple message in this particular simple message class. Send method is implemented and it is sending what message saying simple message, and message sender send message content, send message content. This message sender is again what? Message sender is basically our interface type, right? And that interface type it is using to send the messages, right? And this interface type, iMessage sender is implemented by SMS sender and email sender. Now going to structural pattern main. Here you see what it does. Now coming to this method, if you see, first what I'm creating a platform specific sender, that is message sender, SMS and email sender, right? And then we're creating a simple message via SMS. SC message, simple message, new simple message, SMS sender. Then what we're doing, SMS send. This is simple. Then we're creating SC message, urgent email, and new urgent message, right? And we were sending the email sender here, urgent.email, urgent email.send. So let me run it, and then I will explain again by doing debug so that you will be able to easily understand what actually happening. See, bridge design pattern, sending simple message, sending SMS, hello, this is simple SMS, sending urgent message, then email, urgent, project escalation, immediate attention needed, right? See, this iMessage is this SMS sender and email sender. What these are doing actually? How we have we called their methods? No, we are calling simple SMS and then we are calling the simple SMS, that is SC message, type simple SMS, and we are calling this urgent SMS, which is again your SC message type, right? And what we are doing, we are calling the send method of this particular guy, and we are sending the messages, right? We are sending the messages. But if you see what actually we have done, in this urgent message or simple message, the constructor parameter is iMessage sender. Who is implementing iMessage sender? Email sender and SMS sender implementing this. Right? So now, if you send an email sender object to simple message, it will send an email. If you send a SMS sender to simple message, it will send SMS. Right? So that's how it is. That's how it works. Here, I will do a debug to make it more clear how it works. Now, SMS sender message, who is calling it? You know, it is called inside this particular implementation of SC message, that is simple message. Simple message, message sender, send message, right? That is what you have in email sender and SMS sender, send message, right? This is how the, connecting different codes and passing the information smoothly. We are bridging the problem, right? Now SMS sender and email sender are different platforms where you can send SMS in SMS sender and email sender you can send email. But how you can connect to SMS sender, email sender from your simple message sender? That is what it is trying to tell. You have a simple message platform, and in this simple message platform, you want to use both email and SMS. How you can use? How you can bridge this gap? You can bridge this gap by implementing SC message uh, through simple message. Simple message is the class which is bridging this gap, right? Or urgent message is the class which is actually bridging this gap, right? So this is how the design pattern bridge structural design pattern implemented. So let me start from the line number 22, debug, right? I will debug it for you. Debug Java application. Next, initially what you do, you are in SOP, so go step over. Now you are also creating an instance, no need of getting into step over. In line number 28, you are creating again a simple message, right? Simple message object. But what you are passing here? You are passing a platform. What is that kind of platform you are passing here? You are passing a SMS sender platform to simple message. So what you can do, you can step in to see what actually it is doing. Step in, it went to simple message class to the constructor and passing that to the super, that is SC message. Again, step in. In SC message, you will see this dot message sender equal to message sender, right? So I did a step in, so it came to the object because of super. So this dot message sender equal to message sender. So step over again, step over. You come out of the constructor. So you came now out of the constructor. Object is created. You are in line number 28. Next, step over. Now here you do step in to understand what actually happening. See, it came to the simple message send method. Here we are writing sending a simple message, sending simple message. But what we are doing here, message sender dot send message. And what is this message sender? It is SMS sender, right? So here we will do step over to next line. Now in here we will do step in. You see it came to the SMS sender. It called the send message of SMS sender and it will print SOP and then it will come out from that to send method and it will come out to the method, right? You basically what I'm trying to do and what I'm trying to show you here. See, you have different platforms and you want to connect to different platforms. How you can connect to different platforms through this particular approach. To by taking the bridge design pattern approach, how you can how you can but by taking this bridge design pattern approach, how you can how you can fill the gap or how you can connect different platforms is shown here. So this is how you implement bridge structural design pattern. Now, with this I will end this bridge design pattern session. And with this I will end this design pattern session because you have so many design patterns, right? If I explain all of them, it will go long and long. If you all need to understand, whoever is watching my video, if you're interested to understand design patterns, you can always connect me. I will give you real life example where it is implemented, how it is implemented, along with the current is how they are getting implemented. How the frameworks like Spring it is helping to implement your design patterns without writing so many code. No, Spring is the framework which removes lots of boilerplate code. It allows you to configure and go in the sense it will allow you to just configure, implement. You configure your creational design patterns, you will get that kind of object. You configure, you can configure structural design pattern and you get it. No, that's how it is. If you have any questions, if you have any if you have any questions, if you have any doubt, any concern, you can always message me, comment me. You can always ask me, right? You can always ask me. I'll reply. And if you want to have one-to-one session to discuss about the design pattern, you can always message me, comment me, message me on LinkedIn, comment me on the YouTube video. Also, you can mail me, right? And in some of the video, I have given my phone number. You can always call me also. So here I will end this session. Thank you, everyone. See you in next session.